Hello. Welcome, everyone. My name is Matiisen. As said, I'm representing the Autonomous Driving Lab of the University of Tartu. And today's panel discussion will be about safety as the first priority for widespread adoption of automated or autonomous vehicles. And with me on the stage are three great panelists. Meet Heli Valtna, who's co-founder and CEO of LightCode Photonics, a deep tech startup developing 3D imagery solutions and promising to do it more affordable way than current solutions. We have Ahti Heinla, who's the parent of this cute buddy, co-founder and CTO of Starship Technologies, and they're providing food and package delivery service with these small-size robots operating on sidewalks. And then we have Meelis Animägi, head of safety and quality in Clevon Mobility, who's also developing delivery solutions and automated vehicles that are meant to be operating on the public roads. So larger scale and more dangerous environment, to say. As said, today we are going to talk about safety, which is required to actually have the autonomous vehicles in our public life. It's been long in the air, the promise of having those like taking over our streets, but we are yet to see that. And there are probably multiple reasons why it is so. So before I start talking or asking questions from the panelists, I would like to ask from the audience, when you think about the reasons why we should have autonomous vehicles on the roads, or what's keeping them like being there already, is safety the first reason that comes to your mind? I would like the people who think that safety is the key issue here, like raise your hands. Thank you, and please raise the hands who thinks that the reasons are somewhere else. So it's almost half and half. So that remains to be discussed, like what is actually going on here. But let's then first talk about why we are all working on autonomous systems and vehicles. Why are we doing that? It has been stated that that autonomous vehicles can provide actually like a lot safer road environment, that to decrease the number of fatal accidents on the roads. Is this actually like the main reason, or are we working on it for some other reasons as well? Maybe just for fun or for curiosity, like what lies ahead in the future. So my question, like for you, like to start with, is safety actually the main reason and the first priority in your operations, and like why you are working in this field? And I would like Ahti to start based on your experience. Like what are your thoughts on that?
All right.
Like so safety driven. Is your activity safety driven, or is there something else as well?
I would say we can actually separate two things, okay, maybe let's take a step back. I think the transition from where the society is right now, where like people are driving cars on the road, we're transitioning from that to a point where machines are driving cars. Like cars will be autonomous at some point. They will be pretty much all autonomous at some point. The question is when, of course. And it's a very, very big transition. It has multiple different phases. So I would compare it to a little bit to the humans going to space. Like kind of started there was backstories as well, but the first human flew to space about 60 years ago, right? And and if you look back then it was all about the political rivalry between US and Soviet Union. It was all about who gets to space first, who gets to land on the moon, like 1 year later, 1 year before the other, and so forth. So that was really, really, really important, this sort of political, thing, right? But that was a phase that the whole thing, was just going through. Right now, we don't really think about like rivalry between, maybe, okay, there is some rivalry, but, right now, it's essentially the space activities, the space business is propelled by like private companies trying to do it for like asteroid mining or, something, totally different. So I think, right now in the road-going autonomous vehicles, like I'm also developing autonomous vehicles, but not the road-going, but sidewalk-going. But on the road-going autonomous vehicles, safety is the main, hurdle, that people are overcoming right now, or the main thing, that people are optimizing for. But on the other hand, globally, it's probably tens of billions that have been invested in road-going autonomous technology, so far in the world, and right now it's just investment business. People are investing into this. It's not generating revenue, all that much. So why are people investing in this? Because they expect to get revenue, in the future. So why will be people paying for autonomous vehicles in the future once they are widely available? Is it that they get safe driving? I don't think so. I think they're going to pay for the convenience of not having to drive themselves, or for the economics, for the cost that, okay, they can get a taxi service, a robot taxi service, which is lower cost than the human-based, taxi service. And the third thing that they're going to probably be paying for is that people actually like interacting with machines in sort of mundane situations than with interacting with people. People say that they like human contact, and that's true. They like human contact with their friends, but they don't like the necessary human contact with the taxi driver, with the courier. Like I'm seeing that in our business, in Starship, we're doing delivery robots, right? And we see that people actually prefer getting deliveries with our robots, even if the time and money is exactly the same. They prefer the robots because it's a little bit of an awkward moment to receive this delivery from a human courier. Who is this guy? Like, oh yeah, where is he coming? One of these sort of things. With robots, it's like, wow, it's nice, it's a cute robot. Yeah, I know exactly what it's doing. It shows exactly on the map where it is. It's not that where are you? I'm at the gate. Which gate? White gate. No, come to the other gate. It's not like that. Just see in the map. That's like people like that. Okay, I'll shut up.
Well, thanks. But basically, you're saying is that safety has such a high priority in autonomous vehicles development because it's not so much as an ultimate goal, but a hurdle that keeps us from that. So, Meelis, you as a group member, like a member of a group who's working on Estonian legislation, like for remote and autonomous vehicles, in your opinion, what do you think is like? How can we provide these safeties? Like how much or where to draw the line between safety that will be provided by the technology that you develop and the legislation or the rules, legislation that the country or a municipality can put on?
The line is that the companies that actually develop these autonomous vehicles, they have to like educate the government in these terms. We all have our own this kind of safety system standards that we are working on and according to make the vehicles safety. But governments usually don't know. They don't know what happens on the kitchen side. They don't know the new technologies. They don't know what is going on in the world. So we have to like push it onto them, even though it's regulating heavily your own business is maybe not the eventual goal, but there will be this kind of laws and legislations that will regulate the need to have this kind of safety management on a deeper level.
Mm. But do you think that, or what I'm interested to know is that how much actually can be solved on the technology side, and how heavy or thick or thin needs the legislation be, or can it even be like discussed or clearly envisioned at this point?
It is a little bit different or difficult to explain because each of the company has their own way of working or how to ensure the safety. They have their own software, they have their own mechanical or electronical solutions for this. But the end goal that how the safety needs to be ensured can be written in the legislation. Just not the technical parts that you would have to like have this kind of sensor or this kind of technology, you have the freedom to choose your own way, but you have to find the ways to meet the end goals.
Mm-hmm. Okay, thanks. Heli, I wanted to ask from you is that you're promising more affordable sensors. We know that the current ones are really too expensive to actually have a widespread adoption. But how do you see is that how can you ensure at least the same level safety, or actually the goal is to increase it with the cheaper sensors? How will you do it?
Yeah, so just to start with, I was head of autonomy development for off-road autonomy. So this is a pretty challenging stack of sensors. There are 6 different modalities. You might have about 20 sensors. Cost of them was limited to around 50,000 because we thought beyond that is not acceptable for customer. I mean, you can put any number there, plus or minus, but still it's expensive if you think about, for example, passenger car or anything alike eventually. So, and I happened to be in a place where I had my background in photonics about close to 20 years. I had my research team knowing about new sensors, knowing about new imaging principles that are not applied, but they match really well. And then I knew about a need. And then we had a Ford founder who said, I want to build a LiDAR. It's like, okay, we have a pretty good combination here. And so actually, LightCode was started with the idea that we can make autonomy affordable and in a way democratize it. So, and now, yeah, we can do it. We can make it affordable. We know that eventually, we have already IP submitted that we can fit our technology. I mean, today the LiDARs are like 1 kilo. They are heavy, they are bulky. Elon Musk is not willing to put it on a Tesla, so it's really important. And they consume a lot of power, but the biggest hurdle is that they break down. Because if they would not, then majority of autonomy algorithms could rely on LiDAR, and that would be pretty good. So now what we are doing is we are making this LiDAR compact and affordable. So combining the best of the LiDAR and best of the other technologies used today into this really sweet spot for the customer, and the market is really huge and massive. But this is only the first step. Today we already have IP to package this technology also here. It takes a bit longer than the sensor for self-driving vehicles and service robots. But this is the future. The 3D vision will take over the 2D images, imaging in the cameras, and it will be a new standard.
Will it be safer? Can you say that?
Yeah, because today, as we don't have that sweet spot system, we are combining different technologies according what's the price, what price is acceptable, and what features we can live with, and. It's just either if your sensor is not so expensive, you have to do expensive algorithms. Yeah, you have to heavily rely, for example, on machine learning AI. But collecting the data for training it is extensive, resource heavy, and it's not general. But if we go to those LiDAR quality sensors that are affordable, then they also become deterministic in a way, because you can have deterministic algorithms that work everywhere. Currently, it might be that if you train your AI to drive in Tallinn streets, then you go to Tartu and they don't work anymore. Not to mention New York or any other city that might have some need for that. But if it's a general deterministic algorithm, then you don't need to retrain. You save that money from AI. So this is another disruption, and this also goes to in a way, a Green Deal. You reduce the carbon footprint of this vertical heavily. And I would bring here, I loved Ahti's message that if it's not driven by rivalry or like need for power, it's driven by money. Let's take a framework to analyze the autonomy here. And for unmanned ground vehicles, for defense, there's an ALFUS model. So let's simplify for quick adoption during the panel. And you can think of on one axis, there's the complexity of the environment. And the simplest environment is a straight railroad. You don't have any other traffic there. And if you keep on having like more degrees of freedom, you have humans or other vehicles. It gets more complex. If you have unstructured environment, city is quite well structured, but the next step is like after earthquake or something, or moon. So it's like you can have a really complex environments. And on the other axis, you put the distance traveled without human assistance. So you combine here the mission complexity and so forth, and just like let's have it there. Two axes. And now what we do with it is we can have a quick understanding what the autonomy costs. You have your goal to work in a certain environment and how long you want to drive autonomously. And then you should calculate the area of this shape, and then you like can make it match the cost in a way. And well, you can use a logarithmic scale here. So it means that if you want to drive, from my analysis as a head of autonomy development from past, if you want to drive that environment in the city with human beings without intervening, so it is enormously complex and expensive task. And that's what we are seeing. There are like billions of dollars have been invested into autonomy development. And Waymo and whatnot and so forth, and it's like driven by the vehicles because it is so prominent. But actual work is done, the heavy lifting is done by those machines that have actually really cleverly simplified the task, which means that if you are not dangerous, you are safe. Let's give it Qt factor. This is really important. The Qt factor of service robots is really critical here.
Yeah. Thanks. We will talk about the cuteness and related issues a bit later. But now we have talked a bit about the challenges with technology and also the legislative framework. But I feel it's very important is also to think about what people actually think about. What do they think about autonomous vehicles? Do they have trust in it? Or like what are the more emotional and less rational reasons behind it? Of course, producers would like to provide all kinds of different solutions and promising more affordable and cost-efficient systems, but people are the ones who should use and interact with these machines. And it's about perception, like, is it cute and safe? Maybe they're combined or maybe not. So I would like to know from your point of view is that, like, do we need a change in people's general mindset towards autonomous vehicles? And what kind of changes will be required before we can actually launch the technology into the world? And to open this topic up a bit, then I would like to ask you from Meelis, that you have been said that you're building safety culture in your company. What do you mean by that? And what do you mean by that? That's like, what kind of responsibilities lie there?
It is like, as we are in a new company, even though the development of this vehicle that we have been developing has been going on for several years, now that we have split off from the main Clevon company and started as our own, we are building all the processes up from ground, and this means that we have to push this kind of culture there, that you have to repeatedly say what is safe, how do you act, what kind of way of working you have to use, that never take a shortcut when you're doing something, that because usually it ends up with some issue that will come and bite you later in the development. And this kind of this is like the internal work. And also, as I am working together with Estonian this transportation, then I am also providing this kind of education materials to them that what the safety actually means for a company, how it is developed internally, and what we have to do to create a safe vehicle, and how they have to understand how it functions later, because they don't like I said previously, people usually don't know how things work. There's a lot of software, electronics, mechanics, and in this robot even there's a heavy AI that drives this around, and people don't know what it actually does or how it is created. So for governments, we have to guide them and educate them to build this culture that they know how to improve the overall. Maybe create the campaigns that when companies are launching these vehicles, that people look out there are things on the road other than normal cyclists, pedestrians, cats and dogs, and so there are robots driving now around. So
okay,
it's a cooperation.
Yeah. There's a lot to do to increase awareness in the society, but I'm digging deeper to that personal human level. As just to bring an example from our lab's recent experiment is that people who we have a vehicle which is with a safety driver is providing autonomous is driving around autonomously, and we have people using the car, and we asked from them how much do they trust the system, or were they afraid of using this, and said no, it's also it's cool, progressive, and so forth. And then we asked but what if you remove the safety driver from the formula? And they said no, then I wouldn't trust it. So it's that very personal level of fear versus trust. That's why I wanted to ask from you, Ahti, is that you have experience with these small, cute, and harmless robots. And people tend to come and help them out if they see that they're stuck somewhere. So it's the overall attitude towards these are very friendly. But what do you think when we talk about automated vehicles on the roads, higher speeds? How much of this experience or know-how that you have can be transferred to larger scale, and would it somehow evoke different kinds of emotions from the people that use them or interact with?
I would say that there are definitely stuff that can be transferred, and one thing I think is that when there's also all the on-road autonomous vehicles, the transition from this traditional way of living to this autonomous vehicles type of world, that's going to be decades, and it's been ongoing right now for 15 years, and it's maybe another 15 to go, or I don't know how much exactly. But with the sidewalk robots, it's actually, I think it's the same process, but a much compressed timeline, because the problem space is much smaller. So Starship also had a phase where safety was the #1 thing to drive. And for Starship, this lasted from about 2015 to 2018. That was the time, I was actually the CEO of the company during that time. That was the time then when I, as the CEO of the company, every weekly meeting that we had on every week, every Thursday, I went to the stage and said, hey, here's our current number, our current safety number. We had metrics and so forth. And the goal is to drive that down 250 times. The number of whatever incidents, irregularities, things that we encountered, right? And we did successfully do that in 3 years, or in 2 years. In 2 or 3 years, we drove down the safety, whatever incident, irregularity metric 250 times. At that point, we kind of decided that, okay, actually, that's good enough. And it is good enough. Right now, we have done more than 3 million deliveries, and if you ask what people think about our robots and what they have heard about our robots, It's not that any sort of incidents or safety, that's not actually the main concern. It's actually that, oh, they're cute, what value they're providing. Oh, I get, my deliveries, quicker and, it's more predictable and I like it. And, and for the delivery companies, it's lower cost than using the human couriers and so forth. That's the thing that, right now, I would say the company is focused on. So the safety obviously is important in the company, but it's not anymore the main hurdle to overcome. And I think exactly the same thing will happen to on-road autonomous vehicles. Right now, it's the safety. Safety needs to get to a certain level so that the society decides that, oh, this is safe enough to use. Once that is done, actually there are new things, new hurdles actually. How do they behave in traffic with human drivers in the same traffic? All of these sort of, non-verbal signs that, like, oh, you go first, like, how is that handled with autonomous vehicles? And, if you drive in Italy, how quickly, people will be honking, at your car because you're going too slow, and, loads of these things. So I think these things will be actually as important 5 years from now than maybe safety is now or was 5 years ago for on-road autonomous vehicles.
Okay, that leads me to wonder that we have talked about autonomous vehicles as like the really like new level smart vehicles. But when start talking about the, interacting in environment which has different level of smartness, we should also talk about the infrastructure. And we see that that probably adoption of autonomous vehicles will be gradual, and there will be a long transition mode, period where we have all kinds of different level of smartness on the road. And I wanted, and so let me talk about how resource heavy or investment heavy the whole field is. Then it's clear that the infrastructure all around also should get smarter. But I wanted to ask Heli, you first, what do you think that during this transition period, when which combination would provide higher safeties? Like when we have already these smart vehicles and the dummy environment or infrastructure versus we have a smart infrastructure and a lot of dummy vehicles, like most of the cars today are. Where would you place your bet?
Okay, very good. I come back to the previous topic for just a short while. So what I understood is that safety has like a threshold, or it's like a hygiene. Like you have to have a hygiene to an extent, and after that you can focus on the other things which are become more relevant in a way. And well, it's a good news. So safety is necessary, but not priority. Eventually, money takes over. And let's also realize that the human factor, unpredictability, actually, we can call it human factor or cat factor or whatnot, but it has a cost. Always. And so if robots have to take care or take into account that there are some unpredictable agents on the road, then they can drive slower, they have to stop, so forth. And this actually raises the cost of the delivery and all the system. So I think what we as a human should be aware of that we don't want to add up the cost, right? So let's be reasonable. And that's something there. But once we were asked, what is your special market for the sensors? Don't tell about autonomous vehicles because that's overheated. Yeah, okay, fine. There is a market in the world. Imagine that cars are not smart, but imagine the infrastructure is smart. And it can give you your position and the position of every moving and static object around you. Mm. So that's a game changer, if you think about it. Waymo today has invested a lot of money into self-driving cars, and they own the data. But if infrastructure is smart, then we own the data. And any robotics club could make a new application on top of that. they could find the lost dogs. They could guide the pre-vision people. We could have automatized first aid call for people falling down on a slippery road. And this is, I mean, imagination is just the limit what we could do. If every lamppost in the world would have 3D sensors, which are privacy preserving.
So I understand that you are a strong advocate for smart infrastructure, right? Because so many interesting opportunities lie in it.
I'm
right?
just highlighting that there's an opportunity, but how do you get there? That's the question. But it would open up many possibilities. I believe there are already infrastructures that are smart, but they are like localized. And so forth. But I believe
I wanted to ask actually from Ahti and Meelis, like your companies both are using the teleoperation as a in a way a stepping stone towards full autonomy. But in longer perspective, how do you see how much do you plan to rely on on device sensors versus smart infrastructure? Like, just please give a bit short answers as we're running out of time. Like, do you have a clear strategy about it or a vision or?
We currently, as Estonia doesn't have this kind of many full-scale smart infrastructure, then we do not have the strategy. But we are open to use this kind of open source, open applications that we could layer on and improve our overall safety and this kind of driving. But currently, there is no fixed kind of strategy because Estonia doesn't have this kind of roadmap to give that. How do we grow from intelligent cars into intelligent streets?
Okay. Ahti, what are you thinking about?
Yeah, I would say, for both on-road and on sidewalk autonomous vehicles, I think it's absolutely clear that pretty much any production system will have some sort of operations people, sitting somewhere in the office, and they can handle the exceptions of that happen in these environments, and that is essential for the reason that it's just obvious to have it. If you are suppose even if you have like a super advanced autonomous driving system, but if you have a million cars on the road, it's just like very, very obvious to have like at least 10 people, sitting there and handling exceptions, because exceptions will happen. At large scale, like if you have a million vehicles, you have everything happen all the time, right? And and even at the scale of Starship, I mean, we only have thousands of robots, right? And we are doing millions of deliveries. But our robots are doing a road crossing, for example, every 3 seconds, or three road crossings a second. So as we speak right now, our robots have done thousands of road crossings. Like, even if something happens very, very rarely, it will still happen, right? And it's just very prudent to have a human ready to handle exceptions. But that's for handling exceptions. When you ask how much do you rely on the sensors, of course we rely on the sensors. All the driving normally is done, autonomously with the technology in the robot, right? But there is possibility to handle exceptions. What I think doesn't work is that people sitting there and constantly monitoring each robot. That I have like a screen of 10 robots, and I just watch them all the time, and I'm watching out for exceptions. That doesn't work. Generally, it's been established that humans monitoring autonomous systems do not work. Like you imagine this increases safety. Maybe it does. Yeah, it does increase safety, maybe 3x, but not 100x, right? And we also know the textbook cases, with like Uber, for example, and this is like textbook case. This is what happens in real organizations with real people. People, lose their attention. They don't pay attention. All kinds of things.
Yeah. Thanks. I feel that we could talk hours and hours about this topic, but unfortunately we're running out of time. I would like to take 1 or 2 short questions from the audience before we wrap up.
We have a couple in the Brella app. So Triin is asking, Starship, is it true that your robots thank people when helping them on the street?
Yes, we have found that people really like to help our robots when they see that our robots, or they perceive that the robot is in some sort of a trouble. Actually, our robots very, very rarely get into trouble that they cannot get out themselves. And exactly, for example, this sort of exception handling, that there's a human operator, then taking over control and so forth. But then actually sometimes the person on the street gets there quicker than the operator sitting in our office. So the situation would still have been handled with the remote operator, for example, but the pedestrian gets there first, and we like it. We absolutely love it that there's this sort of friendliness towards our robots. So yes, we have actually programmed a function where when the pedestrian helps our robot, thinks that the robot is stuck, actually six-wheel drive, it doesn't really get stuck really, but when the pedestrian pushes the robot kind of out from something, then the robot says thank you, right? We like that because that's not to be taken for granted. It could have also gone the other way. It could have also gone in a way that, when we put our robots on the sidewalks, then people will call the police. We actually had, they had debates in our company early on where we were not in wide operation yet. That how is this going to be? Is that going to be a problem? Some people in our team actually thought this is going to be a problem. It completely is not a problem at all, but we don't take it for granted.
Thanks. Do we have time for one more?
We have time for this question too, and then one question from Hall. Thomas is asking, is there statistics how many accidents have happened with robots on the street?
Is it to me?
Yeah.
Like all robots on the street. I'm sure there is statistics, right? There Waymo publishes statistics, for example, to California. I think what stuff has happened with them. I don't think that actually, all of the companies operating, they, I think, track slightly different things, and there's no sort of unified statistics, I would say.
Okay, and do we have any questions from the hall? Raise your hand. Okay.
Hello, thank you very much for the lecture. I liked it a lot, and I would like to ask about Starship because that's something I meet every day, I would say. I was always thinking, how does it work when the robot comes to a pedestrian crossing, when there's the button? And I know that there are some places where you actually have to push it. It just wouldn't stop. So how does that work, if you can explain? Thank you.
Yeah, multiple things. First, we avoid these types of crossings. Secondly, there are often still pedestrians around. A robot can actually wait for 5 minutes. It's not a problem. If you are a pedestrian, you're waiting there for 5 minutes, they say, oh, this is a huge problem. Actually, for delivery robots, not necessarily that huge problem. We actually take that into account in our ETA calculations, where our systems learn specifically that, okay, this crossing on an average takes 7 minutes to cross. And that's okay, right? But another thing also is that a lot of these traffic lights are actually connected. And they actually have technology that allows them to either be remotely controlled via a central system, like owned by a company or municipality or something, or they could actually be controlled, with essentially Bluetooth. Because the same problem exists for example, visually impaired people, also ambulances, that they need to actually control the traffic lights or affect them. So Starship is actually working with companies that are operating traffic lights and technologies like that, and we will actually be integrating with them so that we can actually control the traffic lights. But even at the level where we don't control, it's not actually a huge problem. It's a little bit similar. What does the self-driving car do if there is a person who just goes on the road and lies down in front of the car? Yeah, I mean, you can block a car, but it's not really a big operational problem, I would say.
Thank you. To wrap up, I have one final question to all of you, and please answer just yes or no. And my question is that in 10 years, do we have autonomous vehicles all around, widely spread, so to say? Meelis?
Yes.
Heli?
59%.
All right. And you, Ahti?
25%.
That's interesting. Talking about tõenäosus. Sorry.
Probability.
Okay, thank you. Thank you for the panelists, and thank you for the audience for time and attention.